Moin. Jo. So, what's up? Weekend starts early this week in Germany. Weekend has begun officially today. Well, maybe not exactly today, but last workday of the week, basically, for almost everyone. So, I took a look at the both electronics, and with all the knowledge I gained from programming the game controller, I have decided to reprogram the Boat Electronics Sensor Module. Also, heute programmieren wir das Sensormodul neu. Dafür habe ich eine neue Struktur mir überlegt. Nämlich einen Haufen Funktionen, die einfach parallel laufen. Und Timer gestützt. Also Timer-basiert ausgeführt werden. So, was brauchen wir dafür? Wir brauchen dafür ein paar Funktionen. Einmal haben wir hier diesen Engine Monitor. Nehmen wir mal die Engine Monitor.h Datei. Erstmal includen wir die main.h, damit wir alle nötigen Sachen haben. Dann brauchen wir eine eine hull status type def em engine monitor underscore init function. So, diese init function was nimmt sie? Sie nimmt einmal einen Pointer auf. Jetzt brauchen wir erstmal Datenstrukturen. Hey, TMK, what's up? First, we need some data structures. So, do we have holiday tomorrow as well, TMK? So first we need a struct or type def. Struct. We call this engine data. So this is the engine data. Yeah, we will use this thing everywhere. So, and we need a pointer onto that engine data. Pointer to engine data. Was brauchen wir noch? What else do we need? We need I squared C handle type def. Pointer I squared C underscore H. Timer handle type def. Pointer timer handle. So, because what is this thing going to do? Let's write this down. This file contains. Maybe the music is a little bit loud. No, that is better. Oder? Ja, so ist besser. So. Engine checking. As well as handling communication with a master system. So we need a Boolean lock function. Yep, we need a lock indicator. Or maybe I should actually use a free the free RTOS. I mean, we could just reprogram the old system. To think of it, I need the SPI bus, SPI1 for two things, both for the log system, for the log memory, and for the communication, for the wireless communication. Das ist natürlich blöd. That means I need to synchronize operations on the I2C bus. Not I2C, on this SPI bus. Huh. I didn't think of that. Okay, that could be a problem. Rewrite the old software. Maybe that is better. Yeah, let's rewrite also the old software, because that way I don't have to write that much new stuff. Or on the other hand, the new software would give me the opportunity to get this a little bit smaller probably, because down there, this green thingy here, these green bars, they show that there's a little bit of memory left, whereas in the old system, there's basically no memory left at all. And I'm getting errors that, yeah, actually I'm overflowing the flash memory by 15,000 bytes, not 15, 17,000 bytes, and the RAM by 8 bytes. So that means I will have to use the... I mean, how can I do that? I could use a lockout variable. That I set and then reset. Or I'll just make sure within the function that I check if the SPI bus is actually busy at that moment, if a command is being executed. Let's do the status type def load main.h status type def engine monitor init so what else do we need? We need the SPI handle type def SPI handle timer handle type def point at timer handle. So copy. So then we need the initialization function. And here we store a few things to get ready. Then we need a callback to do callback for timer. Welchen hatte ich da verwendet? Which timer did I use? Since I want to use this with timers. I need to use. Okay, timer 1. So I need timer 1 period trigger and the period and output compare. So, okay, let's do that. So, and for that, I am going to first we include engine. Include engine.h. I don't want to have too much stuff in my why are you not seeing that? Refresh. Okay, so we need to include this. Interesting. Why are these two files not being added? Now that's the file. Okay. Or should I just initialize everything from the main function? That would probably work as well. I guess I could do that. And just periodically call the engine monitor functions. For example, how status type def engine monitor check. How status type def engine monitor underscore log write. Status type def those are basically the whoops. What combination did I just press? Windows something something button. Okay. So at brief, what is this function doing? It is function analyzes initializes all variables and monitoring functions, functionality, and starts necessary timers. Also switches on the I2C bus in slave mode. So this makes a brief function to check on engine values if they are within normal parameters. Called periodically to see if engine is healthy. And then last function at brief function to write a log entry. It opens the log file on the flash memory and appends the new entry at the end of it. So then we need to implement some sort of callbacks and timer callbacks to do I2C callbacks. Callback for the timer. Okay, those I can mostly copy from my I/O MCU software. And, well, now I have to fill all this stuff with some meaningful information. For example, the engine type. I think I had this somewhere in here. Yeah. All right. So we are going to copy that file and place it here. Paste. Good. So include this. Include engine thresholds. So okay. So engine monitor initialization. I mean, we can load quite a lot of stuff that is in the main function right now. We can put that into the engine monitor initialization function. Maybe even everything. Although I want sensors to run independently. As well as the... Yeah, I think that's good. All right, so let's see. Is the ADC configured? Where's the ADC configuration? Ah, here it is. Okay, ADC initialization. External trigger conversion. ADC external trigger conversion T1 channel 1. Okay, channel 1 is configured to trigger, what was that, 10 or 100 times per second? I think 10. Continuous mode off. Discontinuous conversion mode disable. We need to switch this on. I don't know. Scan conversion mode on. We are using ADC1. External trigger, yes. Data align right. Number of conversions, 6. And we convert channel 8. 1 to the internal temperature sensor, channel 9, and we set channel 8 because channel 8 has a very high input impedance. And we sample every channel with 239.5 cycles. Okay. So all I have to do is basically just configure the last few things and then start the thing. I think we can put this into engine monitor. I think that is better. Because that's just once, that's just something that needs to be loaded once. And then we need we need some callbacks. Callbacks for timer, callbacks for the DMA transfers. So I have everything in one place. Would that be good? Or would it be better to have this in a separate place and then dump everything over to the other side? This is the RPM capture callback, and this is the ADC conversion complete callback. Or, I mean, I run this check thing every second. Function should check if everything is with the normal parameters. I have an idea. To do update the engine data structure with the current data values. Then compare engine values with thresholds, set reset alarms. That's where I update my engine data. So that means I can run sensors independently. Meaning I can use sensors.h and sensors.c. That's a separate entity. And I need some interface to talk to that part. So I basically have to rewrite that thing. Yes, all right, let's do that then. So I'm going to put everything in here that is to do with the ADC into a custom additional driver. New source file, ADC driver.c, or no, analog sensors, analog sensors.c. New analog sensors.h. Finish. All right. And we basically put everything That has to do with the analog stuff from sensors.h and sensors.c into analog sensors. So what do we have? We have all these defines. Basically everything in here. Copy, paste. And we need the VCC divider. Everything goes over here. Whoops. Yep, this whole thing goes completely over there. All definitions. Then what do I need? I need sensors read engine temp. Yes. Maybe I should reduce this. What do I need? I need an init function. So I need sensors dot underscore HAL status type def sensors init. And what do we need? We need the I2C handle type def I2C internal handle ADC handle type def pointer ADCH. Then we need the timer, of course. Timer handle type def timer H. What else do I need here? That's it. Okay, then I need HAL status type def sensors read. And what do I need here? We need sensor data, which I'm going to type def struct sensor data underscore t sensor data t pointer buffer. So that function can be loaded or can be executed to transfer data from the sensor system to the to a calling function. And this function is being executed once per second. Those are the two functions I need to talk to the outside. Initialize and get data. Nothing more. Those are the two functions. Everything else needs to be internal inside this analog sensor C file. Okay. Let's try to make this as small as possible. Engine monitor C. So that means we are going to call include oops, nope, right. Right, this is analog sensors. analog sensors. Analog sensors does not need the I2C. And since it's running asynchronously, what is the update rate I can get out of the air pressure sensor? Let's see which sensor do I use here. That is a BMP 180. Let's take a look. The BMP 180 is a sensor probably out of production, made by Bosch. Let's see if we can find a data sheet for it directly from Bosch. Of course not. Ah, there it is. Nope. So, really? There's only the data sheets available from manufacturers? Okay. Or distributors? Thought there was maybe some website where I can download it directly from the manufacturer. So we want calibrated blah blah blah. All right, I want the sample rate. Here they say they specify 1 sample per second for all the functions of all the current consumptions. What is the maximum sample rate this thing can handle? If it can handle 10 samples per second, that would be nice. Conversion time, pressure, maximum 4.5 milliseconds in ultra low power. I would like ultra high resolution, so 25.5 milliseconds. A second is 1000 milliseconds, so we have quite a few. 1000 divided by 25.5 is 39.21 samples per second. So 10 samples per second, no problemo. We could even go to this advanced resolution thing. Is there a block diagram of this thing somewhere? Ah, here it is. Okay. So doesn't say if it has some internal microcontroller or something. Some of these sensors have internal microcontrollers, which is kind of interesting. I've seen a a sensor that had a ARM microcontroller inside of it, which was kind of crazy. All right, so we have the analog sensors thing here. Let's quickly write this function, or this system here. Include analog sensors.h. That brief initializes the ADC and the timer to regularly start the ADC conversions. Also makes use of the DMA controller to transfer ADC data to memory. Function to call if API function to be called when ADC or when analog sensor data needs to be read by another function, another subroutine program. So in essence, this is all basically, these are all little subroutines, little programs that are running autonomously, that are being initialized once and then executed autonomously until they are, yeah, until they're finished. Maybe and not until they're finished, just forever. Since I'm using the same timer, I have one. Maybe I need some additional function here, but I don't think so. The timer is being the ADC data conversion is being triggered by the timer that is independent of the processor. So all I need to do here is set up the timer that it triggers the ADC to start a conversion, transfer everything over the DMA to the main memory, and in the callback function do some math. So for that we need sensors.c. Okay, so what do we need? We need internal sensor sensor data T. Oh. Well, why do we get errors? Analog sensors, there's an error, no such file or directory. What? In the main? Typical. Doesn't find. I had this problem yesterday as well, that the okay, let's see if we resource index update, no, properties. It is not excluded. So, das sollte eigentlich gehen. Wieso findet den Krams nicht? Fatal error. Engine monitor. No such file or directory. Are you kidding me? Das Ding gibt es, du Schwein. Okay, what if I just transport this into the core directory? And I hit the build button. Oh, still getting error. Okay. Interesting. Let's place that there. Put this here. And engine threshold goes into the include. Then we delete this directory. Yes. And we oh, now you know the file, huh? All right. Update. Okay, so we get quite the jump in memory and RAM usage. What is using so much memory? BSS. Sort by. What is all this? UC keep. PX ready task. What? Page hunt device. Where is that thing defined? Tasks? Hä? Ich hab doch keine. Ich hab doch den FreeRTOS-Kernel gar nicht an. I don't have FreeRTOS specified, as far as I know. No, only FATFS is active. FreeRTOS is off. Thing is showing me stupid stuff again. Okay, so what do we need? First, we need to, yeah, of course, basically just copy everything that is in here, and then we adapt it to the new system, which means, example, we don't need timer. All right, so what do we need? We need a DMA buffer, and we need an ADC buffer. Copy, paste. So DMA buffer. The ADC buffer is not necessary because we have that in sensor data. ADC buffer size. That is number of samples. So that we should be able to grab from the ADC configuration. So where do we get that? We should be getting that from HADC init number of conversions. All right, so although the thing is, shit, I need to create that. If I want to use that information, I would have to create that array at runtime. How do I do that? malloc? Let's see. Let's ask ChatGPT. How do I create an array in memory to store information that I do not know the size of at time of compilation? Can I use malloc for this? And if so, how? How can I use malloc to create an array in memory for an initialization function that is then going to stay in memory and be accessible to other functions in the same .c file. Ah, great. That bug was annoying me yesterday as well. Can follow these steps. Pointer array. Okay, so I need int array and the size of that array. Alrighty. So okay, good. So we have, let's create this thing. So this is gonna be uint 16t ADC DMA buffer. Then we run malloc. Okay. So clear data buffer. Well, first we create the data buffer. Create data buffer for DMA. ADC DMA buffer equals int 16t star malloc ADC dot ADC underscore h dot init dot number of conversion times size of int 16t. So then we run a check. Copy, paste, and of course we need to include probably stdlib.h. Let's see if that compiles. Oh, all right. If ADC DMA buffer equals 0 null, then all right. This is when the allocation fails. Okay, we don't have a sensors error variable. Then we stop the ADC in case it is already running. After that, we run the calibration function. Then we use memset on the ADC DMA buffer. To make sure it is 0. Image number of conversion. So incompatible implicit declaration of built-in. What? Why is this incompatible? Memset void integer size t. Huh? 0 and the size. So I mean, this is the size of that thing. Copy. We have this. I have to use dereference? No. String.h memset pointer integer. Maybe because it's a 16-bit value. Instead of a normal integer value or something. You know what? Just gonna use a little for loop. For uint 8t I equals 0, I smaller than adc h dot init dot number of conversion I plus plus. ADC DMA buffer I equals x 0 0 0 0. That should work. Yeah, that gives no complaints. All right. ADC step size is undeclared. It was a float here. All right. Let's place it here. Float. ADC step size. We set this here. What else do we have or not have? Again, ADCH. ADCH dot init dot number of conversion. I really think I should have the ADC handle somewhere up here. ADC handle type def pointer ADCH. ADC handle. Okay, so just in case I need that. ADC handle equals ADCH. Just in case I need this thing. All right. Okay. Don't need that. It's not hull. Okay. That means exit 1 print f. So what does printf expect? Incompatible implicit declaration of built-in function printf. All right. error message ADC start DMA fail \n. Okay, let's make this every error message needs to be as short as possible because we want to save memory. Right now, 36.48 kilobytes are free. So, timer age is not declared. Do this now, all right. So there's nothing that to do with the air sensor. And since we are running here, so return HAL, okay. This means we also don't need result. That's another, how big is this? That's another byte of RAM not used. Which one is this? This one, right? Yep. Jo. Nimmt so langsam Form an das Ganze. So, was gibt's hier noch für Errors? Multiple definitions of ADC DMA buffer. Was? In sensors.c. Ah, yeah, all right. Of course. Sensors.c now has to be cleared of all this stuff. Basically, sensors.c is not being used anymore. Remove it here. Call it analog sensors.h. And we are calling analog sensors init. Analog sensors initialization. With HADC1 and HTimer1. HADC1 reference HTimer1. Still error. Sensors.c is somewhere being called. Okay, so let's create a folder, new folder, legacy. Legacy drivers. Paste. So these two go over there. Okay, now it compiles. Wanting control reaches and okay, that's expected. This, I don't understand why I'm getting this error message. So, of course we need to set this up differently. HAL timer underscore start. HAL timer start, base start. Starts timer base generation. Question is, should I start the timer base before I start HAL ADC start DMA, or should I start this afterwards? Well, we will see. All right, so void HAL ADC callback. Paste. All right, so now we need to grab the data from the ADC buffer and plug it into the sensor data. Sensor data will be int 16t. What inputs do we have? We have analog inputs. What is the what is the order of reading stuff? ADC, there we go. ADC channel 8. So first we describe this. Let's brief ADC DMA buffer contains DMA controller writes data here. By the way, how well is this visible on stream? This whole thing. I have not checked. It is readable, right? Oder nicht? Doch, sollte readable sein. Ja, kann man lesen. Das sieht auch übrigens im Stream ein bisschen anders aus. It looks a little bit different on stream than on my display here. Stream actually has higher contrast than my PC monitor. Okay. DMA controller runs data here. Memory map. First is DC sense. Then comes channel 1. Channel 1 is throttle position. So channel 1 throttle pause. Channel 2 is temp head, internal temp, or CPU temp. Next is channel 9, which is VCC sense. Und der letzte ist DC Sense. Discard. Oh, no, this is the right. Should be correct value. Discard this value potentially unstable. Actually wrong due to RC due to high source impedance. Okay, so let's rewrite this thing. We won't average stuff. We will do. I found this yesterday here in ChatGPT. Where is it? Low pass filter. Okay, so let's ask ChatGPT for a low pass filter function. Can you create a software low pass filter function for data that is being read 10 times per second and has a cutoff frequency of 1 Hertz. The data is a and 16T value from an ADC. Copy. I hope I can call something like this. So function prototype. So alpha determines filter strength. Okay. And will give me a function that sets alpha depending on based on the cutoff frequency in Hertz. Hertz expressed as a range 80 value. Okay, so I need to, all right. All right. Good. So we have a low-pass filter function that we can call from here. Can you rewrite the low-pass filter function as a macro? All right. This is exponential smoothing. What is the difference between an exponential smoothing, low pass filter, and a finite impulse response low pass filter? Two different. Commonly used for applications that require simple and lightweight filtering, such as noise reduction or smoothing of slow changing signals. Well, that's exactly what I need. Lightweight because executed in an interrupt. So I'm going to use the macro version because calling a function might create additional overhead unless the compiler is capable of deleting this overhead. So let's start. So ADC conversion complete means we are done with the conversion. Now we start start to convert this value. So we have that means we will have sensor. Oh, right. I have not populated sensor data yet. Sensor data will be throttle pause, T temp head, and 16T DC sense. Oh no, VCC sense. and 16 T DC sense CPU temp or temp CPU. So we start with the first value, so that will be sensor data dot right. First we have to run the compiler once. Error. Yes, of course. Sensor data dot DC sense equals so no pass filter, yeah, no pass filter ADC value, so load ADC EMA buffer 0. Then the filter the values, then sort data dot DC sense and the alpha value, which we have to create here. Load alpha equals, well, let's just define this alpha value. Define alpha LP F alpha oh no, I want this load alpha, and then we have here a little function to calculate alpha. Where was the alpha function that we can calculate here? Right, there we go. And of course the sample rate. Sample rate somewhere. And 16 T 8T sample rate. ADC sample rate. So we do calculate ADC sample rate from timer settings. Sample rate equals 10. Debug sample rate to do calculate proper value. Okay, and then we calculate the alpha value. Alpha equals calculate alpha. Cutoff frequency, which we can define. ADC LPF cutoff frequency. Good. and ADC LPF cutoff frequency will be set here. Let's set this to 2 Hertz. Cutoff frequency of the ADC LPF in Hertz. Good. Compile. Cross loads of errors. What is here? Expected expression. What? Two, three, 2, 3, 2, 1, 2, 3, 4, 3, 2, 1. 4, 3, 4. Wait, normal. Okay. Das funktioniert nicht. Wenn nicht, habe ich jetzt keinen Bock drauf, da lange noch drum rumzufummeln. Dann nehmen wir einfach die Funktion hier. So. Kopie. Pasta. So, Copy. Whoops. I wonder if this will work, or if this creates extra. So MPI. How do we get that MPI? Times cutoff frequency. Aha. MPI. I would guess that is pi. Include math.h. Oh boy. Math is a big one, I think. Be a big library. So all this goes away. Yeah, we don't need all this. Yeah, because I'm not doing anything there. All right. So Long pass filter, float ADC, and the end is alpha. Alright, ADC step size. We don't use this. Instead, we are going to use the raw value from the sensor vref int. CDMA buffer. Compile. Wait, only one line of code still wrong. And that thing also belong there. Source format. So sensor vref int is not the right one. Or reading the vref internal. Oh, right. I had a calibration function in here. Probably should keep that. Analog ADC1, vref internal, and that means number of conversions is 7. So, channel 8 set there, 239.5 cycles, and this is going to be vref internal, 239.5 cycles. Good. Save, use. Okay. Now we have to find the order of data that is being transmitted. Okay, so first entry is DMA buffer sensor DC volt should be 0. Okay, that means we have to change all that. So DC volt is 0. Then comes throttle position, head temp, VCC, no, CPU temp. 3. Then comes VCC at number 4. And then comes vref internal at number 5. And number 6, which is 7. The 7th conversion, channel 8, is don't care. Okay. I'll just copy all this several times. 1, 2, 6. There we go. So we run this thing. To change this parameters. Second. Number 2 is throttle pass. Throttle position. Sensor throttle. And yes, I know I don't have a throttle potentiometer, but I could install one in the engine. That is sensor data. Third one is temperature head. Temp head. Cylinder head temperature. Sensor. Head temp. Sensor. CPU temp. Sensor VCC. Sensor VREF internal. Right, and forgot that. We need one more value in 16T VREF int. Temp CPU. CPU. Okay. Compile. It compiles with no errors. Nice. All right. So this callback writes the data from the DMA buffer into the sensor data structure. And now I have to calculate the actual voltages. So for that, I had some functions here. No, we don't do the voltage conversion. We do that once the analog sensor's read is being executed. Until that point, we only have raw values there, which is a bad idea. I just realized, no, damn it, I need the damn. I need raw data, sensor data raw, and sensor data normal. Okay. Sensor data T, sensor data out. No, don't do that. We take the raw values, calculate that, and transmit it directly. So buffer dot DC sense, for example, will be copy all this over to the new function here, to this new library. Okay. Auto position, engine, RPM, that's not part of this library anymore. Although I could put it in there. Oh, this is analog sensors. I will have a dedicated driver for the RPM sensing. These are private functions, so they're not exposed anywhere. And I think I will use yeah 8-bit integer. Or 8-bit integer, what is that? 128 plus minus 128. Why did I use that? Why did I use a 8-bit integer? What is the accuracy of that chip? Let me check something. What is the accuracy? Accuracy. Give me the precision. Yeah, plus minus 4 degrees Celsius accuracy. Yeah, no. No, I don't need higher. Although if I want to read up to 150 degrees Celsius, I need more. Let's ask ChatGPT. Does it make any difference apart from saving SRAM on a STM32F103? That's the STM32F103 using 8-bit integers on a STM32 instead of 16-bit or 32-bit yield any speed increases, any advantages despite less memory usage. Data precision, yeah. Performance. Really? Interesting. Okay. I mean, yeah, I think that was the reason. There's never going to be a... Yeah, there's never going to be a situation where the engine temperature is above 120 degrees, I think. Right? What? That's cool. That is cool. Nice. That is cool. That's cool little thing. What would I call this? Stream brace? Stream brace. Yeah, that would be a good name for that thing. By the way, I think I have some paper modules somewhere here as well. That's OLED display. Huh. I thought I had some displays. I mean, I'm sure I have one somewhere. But I don't know where right now. Hmm. So we have here the sensor. Buffer DC sense equals sensor data DC send. Wait, no. That is gonna be sensors underscore read DC. Data is yep. Sensor auto millivolt. And this is gonna be, damn it. Okay, the architecture of the old program was a little bit different. I had that as an array. Okay. That's 1, 2, 3, let's say 4 multiplications. How long does the STM32F103 take to execute 4 multiplications, including the loading and storing of 32-bit value, float values, right? Let's go with float values. Float values. CPU is running at 72 megahertz clock. Single cycle multiply for nice. 4 multiplication will be 4 memory access. 13.89 nanoseconds for 1 cycle, so 12 cycles. According to ChatGPT, the processor will take 166 nanoseconds to calculate everything. That means I think I will go and just use an additional structure. Or, additional structure means 2, 4, 6, 8, 10, 12 bytes of memory that I don't absolutely need to use. Okay, so I'm not going to do that. But I'm just going to rewrite these functions here. Channel. This will have a switch thing now. Channel. I'm going to remove that because it's just going to be result is going to be sensor data dot DC sense times what was this? Times ADC step size, right? Yes. Times ADC step size times DC volt divider. So data CPU temp times ADC step size minus CPU temp offset times CPU temp MV step. Missing what? Error? Expected statement before close bracket token. What? Oh. So first we have the voltage minus CPU temperature offset times CPU temperature millivolt step. Yeah, not compiles. Okay. Format. Good. Then we have this thing. Sensor data, throttle position times ADC step size. Yeah. And one last thing. Temperature head times ADC step size. Okay. That should take care of that. So now all I have to do is buffer. Temperature head equals sensors. Read. Where is it? Engine temp. We have to give the sensor type. Okay, how do we find out the sensor type, by the way? Okay, I need one more variable apparently. And that's gonna be head sensor type def. Head sensor type def. Sensor type. Head sensor type def. Sensor type. Let's put this as a pointer. Head sensor type, and here we want head sensor type. This will reference that value. Then we get, so this transfers, yep, so we have the head sensor type called sensor type. I don't think that I need the ADC handle at all, do I? Nope, I don't think so. Okay, then that means we can delete that. Delete this. I only need the ADC handle type, the ADC handle here to set it all up. Once it's set up, this whole thing will just run on its own, I hope. Error? What error? Huh? Incompatible type? What? Why? activated. Still error. Why? Ah, not enough arguments. Okay. What do I have? I think engine check. What was I using? Sensors initialization. Rate sensors. Ah, there we go. Work data set. Head sensor. Okay, that means that we have to get from somewhere. But for now, we set it to MCP 9700. To do. Get the sensor type for head temperature from the flash memory. Okay. Building. All right. Let's take a look. What is that? Node red? Okay. Interesting. It's calling it cheap deck. Okay. Interesting name. So somewhere he has a server running or a program running on a PC that receives data from this cheap deck and is then creating creating the message to OBS. What is this? Passing argument 3 of analog sensors make pointer from integer without a cast. What? Ah, okay, because it's a let's make it simpler. But let's not use a pointer for that. What? What is the error now? Invalid type argument. Oh. Now it works. Okay. I think, I'm not sure, but I think, well, at least, I don't know how the loop deck does it. I think it does it in a similar way. Probably the Stream Deck as well. But Stream Deck might actually have some other API access to OBS. That I don't know right now. Okay, so let's check this, let's go through this program in form of desk checking. So from main, I'm calling analog sensors initialization. This function then sets up the DMA buffer, sets the sample rate to 10, calculates the alpha value for the low pass filter, then it stops the ADC, calibrates the ADC, sets an initial value for the ADC step size. Oh, first it clears the DMA buffer, then it starts the ADC, and it starts the timer. And after that, it returns with HAL OK. We don't use HAL error here. We do return HAL. I mean, not exit. We use HAL error. So, and then once this has started, the timer is going to trigger the ADC 10 times per second every time the ADC has completed a conversion. This function is called, which then calculates the new sensor data value, which is all raw sensor data. And this raw sensor data is then being transmitted to the buffer here. And that function has not been completely filled. Buffer, throttle position equals sensors read throttle. Buffer, CPU equals sensors read CPU temp. Buffer, VCC sense equals sensors read VCC. Air pressure and air temperature, these will be in a different function. Okay. Save. All right, I think we can upload this for now. Let's place breakpoints there and in the DMA callback. And I'm going to see if this works. Initiate upload. Yeah, basically also how the no-alp system works. So run. Okay, little problem. The ADC conversion complete callback is not being called. Which means that probably how timer base start is not working. All right, let's go here. Check this. All right, so it goes in here with HTIM is HTimer1 instance channel active channel cleared. Maybe I need to set the active channel. Next. Next. Timer trigger enabled. And okay. Huh. All right, that doesn't work. I mean, we don't exit here, so that means the ADC is correctly set up. And we don't crash. Okay. Good. So that means how timer base start doesn't work unless we have to do timer h dot active channel equals tem channel 1. Let's see if that helps. All right, and I have to go somewhere. Be right back. Oh, yeah. I have a problem, chat. Tomorrow is a public holiday in Germany, and I just realized I have just one roll of toilet paper. Oops. Okay, that doesn't work either. Hmm. Hmm. Okay. Let's ask the AI, ChatGPT, how to do this. How do I configure the timer TEM1 in the STM32F103 in a way that it's that channel 1 of the timer periodically triggers ADC conversions with the ADC configured. She teaches English but does not know all the words in English. Okay. Is she from Japan or is she living in Japan? Because I think there are quite a few only started last month. Okay, then I definitely don't know her. I basically know almost no Japanese streamers. I know Cash Meow. I think that's it. Uh, let's see if ChatGPT is able to point me in the right direction. Okay, so you have to set the timer first and then start the... Okay. Well. Set prescaler stuff, blah, blah, blah. That's already done in the CCMR. Timer channel 1. Output, compare 1M. Set the compare value. ADC1 control register 2, CR enable. External select 1. Okay. Number of conversions set. That's being configured somewhere else already. That's somehow a thing in Asia, right? Parents constantly asking, why don't you have boyfriend slash girlfriend yet? Or husband slash wife. Seen who was Pumpkin Pim and Babymon when they were in Taiwan. They I think maybe Barry also, they were all running to these temples to pray for boyfriend. My opinion on that whole matter, just stand in front of the temple instead of paying the temple and praying. Just stand there and talk to guys that go there. Japan has the Japanese have an R in their phonetic alphabet. Interesting. Well, we might be. We could raid her. Probably not today because today is Ira's birthday, so we are going to raid Ira later. But yeah, we could raid that Japanese Ira streamer next time. So let's take a look. Is the ADC configured to have the conversion? Yeah, it should be. Okay, so ADC 1, 2 global interrupts are on. DMA channel 1 is also active. DMA settings. No external trigger, external trigger conversion source. Select the external event used to trigger the start of conversion. Maybe we'd have to regular trigger? No, that just sets the PA1. Okay, that's also incompatible with this setting. Okay, so timer 1. Compare. Enable that. Okay. Oh no, this is output compare preload. Don't want that, I think. Okay, so should work. Most online when we work. So streaming during the daytime, during Japanese daytime, or no, Japanese evening time, right? Cheers, prost, or skull. I'll just use the compare. Let's just set all this manually. All right. Let's compare the timer registers with the values that ChatGPT generated. Okay, so we are returning with a hull. Okay, that is good. That means everything has been set up. So now hull time base start. Let's take a look at the SFRs. SFR timer bay timer 1. Okay. CCMR1 should be timer CCMR OC1MO. OC1MO. Okay. Look. This would set that to, yeah. Okay, so that doesn't work. Well, in that case, we will have to, okay. CCR1 is set to 3E8. Okay, that is correct. Show this in a, give me that data in decimal, please. Doesn't want to. Okay, then don't do it. Good. So, and then timer 1, CR1, timer 1, control register 1, C enable, timer is enabled, but the capture compare mode register has not been set to the right value. Stop. Okay. Update. Let's see if this works. I think Japan has some pretty nice spots. Okay. But I still don't get the ADC conversion complete callback. Perhaps because I need to adapt the interrupt service, the interrupt file here. Manage handler, blah, 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 DMA channel 1. DMA ADC 1 IRQ handler. Okay. Let's take a look. What did I do in the other program? I think I might have changed something there. Let's take a look. Did I change something here? No. I didn't change anything in the interrupt file. Take a look at this one. Open declaration. No, that is just the... Oh, okay. How ADC conversion complete callback. Uh-huh. And that is found in the hull adc.c file. Question is, are we overriding it? Because we have to override this. Right occurrence of that function. And this is doof. Okay, so we need to go in here, drivers, hull driver, source, ADC. Now, how do I make sure that thing is executed? Because I'm right. Well, maybe. Well, let's see. See if I set the breakpoint there. Hehe, nope. ADC conversion complete callback is not being executed. Never executed, actually. Okay, let's pause. Take a look at the DMA buffer. ADC DMA buffer. Okay. ADC DMA buffer right now set to how does this work? So that's the memory address. Okay, now it is set to this memory address. Let's go there, copy. Memory, monitor, paste, go. Where's the address? Okay, there it is. Now we run through to that point. 4 Charlie 0, 4 Charlie 0, right there. F8. And this has been set to completely 0. So all of the memory locations have been zeroed out. And now we execute the program. Run it a little bit. Pause. Wrap. Okay, no ADC transfer has been executed. That sucks. What the mod enabled is off. ADC enable. ADC on. Okay, ADC DMA conversion complete. That is it. All DMA on. DMA. Okay. So that all starts. Still don't get the conversion complete callback. This is just not being executed that part. Hey, someone. How's it going? Tja, in der Theorie sollte das alles laufen, aber in der Praxis läuft's nicht. So it should be running in theory, but for some reason this is never called, which means that the analog digital converter is never doing the stuff it needs to do. Unless, of course, number of conversions is 0. Let's take a look. Number of conversions. Okay, so we're in here now. Let's take a look. Number of conversions. Init. Number of conversions is 7. So how ADC start DMA. Jump in there. Let's take a look. Length is set to 7. Okay. That should work now. Ja, mach mal. Das ist bestimmt interessant. Okay, so DMA data transfer is not working. The fact that the memory monitor doesn't show any change in the memory content says that the DMA transfer is never starting. Okay. Huh. Why? ADC is configured as independent mode. Continuous conversion off. Scan conversion on. Do I have to set discontinuous conversion to enable? I would find that strange, but okay. Injected conversions off. What if I enable that? 1. And then I have to set the channel. Okay, so this is definitely not what I want. So either I don't get the trigger, or I don't know. Okay, let's try it with discontinuous conversion mode. Kollege ist zurück. Jupp, bis später. Ja, geht mir ähnlich. Aber meistens ist das so, das Programmieren-Stream lebt davon, dass es halt, dass man ständig in irgendwelche Blocker reinrennt und die dann nach und nach kurz und klein haut. Let's take a look if this works. Timer based on. Let's check the timer. Is set to the right value? Yes. OC1M1. Output compare one mode. Okay. Execute. Check memory. Not show it in hex. Pause. Yep. Data is not being updated. Great. Okay. What if I set this to timer OC start? Timer 1, PM channel 1. Let's see if that works. That generates the necessary maybe it does, maybe it doesn't. Let's see. Everything is set up right now, so it should work. I have the period, I have the counter, I have the prescaler, I've got the output compare registers. All registers are set up, so it should work. Let's take a look. Timer 1. CCMR1. Interesting, what is this? Okay, capture compare enable register. Ah, interesting. This now has control register is enabled. Status register shows interrupt flags. Okay, so we've got interrupts that have been called. Or is this the, no, this is status register. So status register says interrupt has been caused by something for every single one register. Update interrupt. Capture compare one interrupt. So all 4 capture compare interrupts have been flagged. Means the interrupt handlers should be firing. I can always use this with a no, I could always do this with software interrupt or an interrupt and then launch the ADC there. That would work too. Let's see if we can find the interrupt callbacks. I wonder, HDMA ADC1 X for complete, DMA complete callback, ADC DMA complete, ADC DMA complete, blah, where is it? Find this here? Nope. It's not in there. Not in there either. Nope. This is annoying. Sure. So, okay. How to use timer 1, STM32 timer 1 ADC trigger. Let's see if I can find something in the forums. Okay, so PWM generation, no output. All right, let's see. Timer 1. PWM generation, no output. Maybe I had the wrong mode. Because I had an output compare mode. Okay, so PWM generation, no output. Then set all the register, all the period and compare registers. Okay. Maybe I had the wrong mode and that was it. That would be nice. And how do we start this? We execute HAL timer PWM start. Okay. HAL timer PWM. Oops. I'm just going to PWM start. Timer 1, timer channel 1. And then okay, and before that we've initialize the ADC. Okay. Good. ADC calibration, ADC start ADC interrupt. Okay, we use DMA. Then we launch the timer. Let's see. Execute. Still doesn't like that. All the interrupts have triggered. Count register is counting. register. Is set. Why is the CCR1 not correctly set? Okay, maybe I still have 1 or 2 errors in my setup. The timer, let's check again. So we have timer on PWM generation. No output. Counter period. Okay, we don't care. Trigger output. Disable trigger event selection TRGO. Trigger event selection. Update event output compare. What? Okay. Master slave off. Trigger event selection TRGO, update event. And then trigger event selection TRGO2 is set to reset. Okay, maybe set that to update event. I don't know. Wait a second. Why did this thing delete my values here? Damn it. All right. What did I calculate yesterday? We have 2 million divided by 72,000. And we want 10 conversions. Okay, so this one will be 1,000. And the other one will be let's set there 4,000 something. Four. $72 million divided by 10,000. Divided by 4. 2,500. No. Quatsch. 10,000. So this triggers 10 times per second. This triggers once per second. And the counter period that triggers every 5 seconds. Okay, let's try again. Save. Generate code. This has to work at some point. Debug. Oh, I'm already down 1 Schwipschwap and almost 1 beer. Still not working. Okay. At least the counter registers are now set to the correct values. Okay, what is the ADC set to? ADC status, ADC1, status register, Regular channel start flag. Okay. Meaning it is probably doing stuff. Let's take a look at the ADC status registers. That's the reference manual. ADC is the ADC, analog to digital converter. Registers. Status register. Regular channel conversion has started. Okay. Control register. Discontinuous mode on regular channel. Okay. Maybe we need to disable discontinuous mode again. Disable. So, continuous mode disabled, scan conversion on, enable regular conversion, yes. External trigger, source, timer, trigger, event. Okay. Timer capture compare. Set to capture compare. Take a look here. Select timer CC1 event. Timer 1. How do I get that CC1 event? Channels. more idea. Maybe I did something in the main function in my old software that I haven't done in my new software. GPIO. SPI transmit complete callback. No. But I think... Did I have this, the sensor here? No. Or did I have the, do I have to put sensor.main, sensor.h? No, it doesn't need to be there. All right. This sucks. Why does this not work? Hmm? Ah. Ah, now it works. Perfect. Okay, let's take a look at this memory location. Hex, decimal for Charlie. We need the ADC DMA buffer app. For Charlie 0. For Charlie 0. There's the data. Let me stop now. Okay, disable. Run. Okay, good. Now I need some sort of GPI. How GPIO underscore write pin CPU LED. Damn. I have not set the LED. Analog sensors needs to include main.h of STM32. Good. And then we can use this copy. Paste. So ADC set to this discontinuous off, continuous off. What else? Scan conversion on, number of conversions 7, then the timer to PWM mode. And now it seems to be working. Well, kinda. Apparently, this function is called from time to time, but not very often. Yeah, every 5 seconds or so. Okay, so something is wrong with the timer configuration, but it is working now. So timer clock 72 megahertz for all the timers. Good. Okay, so timers are running at 72 megahertz. We have no internal division. Prescale is set to 72,000. And it should trigger 10 times per second. Let's set that to 10,000 and disable channel 2. That now triggers the timer once per second. Then we know that it triggers on the counter period instead of the PWM setting. Output compare preload is enabled. Maybe I need to disable that. Well, let's take a look. Timer configuration. Doesn't say. One. Capture compare CC1. And TRGO source has to be enabled. Okay. All right, let's see. That increases the frequency with which this timer is triggered. Yeah, okay. So it triggers on the counter period instead of the capture compare period. Geil. That is bad. Although, wait. Huh. Of course. course, it cannot trigger that. Can't work what I have in mind here. Crap. Of course, it cannot work. Because the timer damn it, how do I do that again? So after 1000 counts, this triggers. But the counter period is 10,000. So it counts from 0, 1000, trigger, and it continues to count all the way up to 10,000. Then it jumps back, of course. Huh. Well, that sucks. Okay. Well, then I'll just enable another counter. Interrupts on. Channel 1 off. Okay. And we're just going to use this timer as the time base. Yeah. This is gonna be my 1 second time base, 7200 minus 1. Counter period 10,000. No internal clock division, auto reload off. So this is gonna be output compare PWM generation, no output. Trigger at 5,000. Fast mode. What is fast mode, by the way? What is fast mode? Control F, fast mode. In the timer context. Oh, great. Doesn't say. Yuki. Counter modes. Okay. Then we're just using 2 timers. And set this to 500. And this is going to be set to 1000. So that's my time base for the ADC. And then the other timer, timer 2, will be this time base for for the software loop that checks the engine data, writes the log file, and all the other stuff. So timer 2 will be the time base for the... Actually, I could just run that in software. And check the systig timer. Let's ask ChatGPT how long it takes for the sysdig timer to roll over. How long does it take for the sysdig value in the how to roll over? 32-bit variable rollover is 60 seconds. Okay. Okay. Rollover after 60 seconds. Well, that is not good. That I cannot do much, I think. I have to constantly check. No, I'll just use a second timer and count seconds. All right, upload. What? Still only once per second? Did I forget something? Timer 1. Oops, I didn't set the period correctly. Okay. Save, yes, yes. Upload. Okay, 10 updates per second running. Good, stop. All right. So, engine monitor check. We'll grab. First we need engine data. Engine data T, engine data. Engine data. And in there we need to include analog sensors. So this goes into the other. And one of the values will be sensor data. Data, sensor data. Damn. Shit. How do we... Oh boy, how do I get that sorted out now? Nested structures with nested structures. Okay. Okay. Maybe I need a temporary variable. Analog sensor data. Analog sensors equals set and then we call sensor read. No, sensors. Analog sensors read. Analog sensors. So just like that. Timer. Engine data does not need to be here. This will keep engine data. Let's see. Okay, timer. Start. Alt TIM start. PWM. Start. Interrupt. I can base. Start. Timer H. That should starts the time-based generation interrupt mode. That should trigger a callback. Callback for timer void. Timer. Okay. What is the callback for the time base mode of timer 2? HAL time period elapsed callback. Okay. Probably have to call that from the main.c file. Because in there we have to check for the timer, which timer is this coming from? And then we count up the log seconds. And loop count. ENG the loop count counter for main loop. 1 second has elapsed. Can we do this all in the HAL timer call, period callback? Paste. So if HTIM to write this myself, just copy this over. If timer instance equals timer 2 in this case, timer 2 loop count plus plus. Log count or log seconds plus plus seconds plus plus. Increment the counters values for the check, log, and functions. So, and then in the while 1, we just super simple, we check if loop count is not 0, then engine monitor check loop count equals 0. If seconds is larger than, let's say, 5, we do call the communications function seconds equals 0. If log seconds larger than 60, to do call the log function log seconds equals 0. So this will be a pointer. Start the time base at the very end. Would be So last check. This thing works. Of course it doesn't. Right, because I never call engine monitor initialization. That is the last thing I do. Engine monitor check. Check init with pointer to engine data. Engine status. HSPI 1 timer 2. Just for test purposes, this will change. Oh, right, engine status doesn't exist. Let's correct that. Engine data. Engine status. That's some value I need access to from a lot of different programs or subroutines. Yep, nice. Okay, every second the timer period elapses being executed. That means we get the tick for engine check and all that other stuff. There we go. So, and it's being transmitted to that point. Analog sensors. Okay, temperature head is set to, I don't know what value here. Some crazy value. That is wrong. Throttle position could be correct. VCC sense. That's right. 3.258 volts. Yep. 21 degrees on the CPU. 2048. VREF in. Maybe that's a little bit wrong, but okay. But 21 degrees should be right. Is there a special reason since you're from part of the world? No. I just find that area interesting. That area of the world. So the head temperature is definitely wrong. Let's see why that is. Check the engine temperature. So we're getting temp head 290. Okay, temp head 290 times ADC step size is a value of 231.38 volts, millivolts. Let's check that. Two three two millivolts. Yep, that's correct. 5. So minus 500. Subtract the offset voltage, which means the tempered result now is minus 268. Temperature MV step result is now 0. Oh, right. TMP result is minus 26. Okay, that means we are not using the right head sensor type. So let's set that to 0. LM35. Run through this little subprogram. 23 degrees. That's correct. Okay, so I have a LM35 installed there. Okay, didn't know that. Good. Good to know. So I need to change that to LM35. And with that, programming is done for today. Let's see if Ira is still on. Seems like it. All right, so we are going to raid over to Ira now. Wish her happy birthday. And I'll see you guys again tomorrow for some gaming stream. Until then, thanks for watching. Thanks for putting up with all this thing around. And yeah, until tomorrow. Well, later today. Good night.